Hello, my name is Darren Holmes, and today we're going to be using the Primer Trainer, and we're going to be taking a look at lesson number 1 using the Monitor operating system. So following along the instructions, the first section is on viewing and changing memory contents. It says when you first turn on the Primer Trainer, the display marked address register pair will show FF01. The number on the address register pair displays the value of the program counter register, PC, and the number on the data op display is the data at the memory address pointed to by the program counter. So turning on the Primer Trainer, you can see that the address register pair displays display FF01. This is a memory address location in either the expansion RAM or the 8155 PPI. Over here where it says data or OP, my display says DB. Yours may display something differently depending on who used your trainer last, so any number could be in here. This just happens to be the program entered for lesson number 2, and the first memory address location FF01 is displaying that data, which is DB. So please notice that on these 7-segment displays, a D is a lowercase letter and a B is a lowercase letter, because if we tried to put a capital B in there, it would look like the number 8. So D is lowercase and B is lowercase. So when you first turn on your Primer Trainer and an address and data at that address is displayed, the primer is said to be in data entry mode. So I'm now going to continue on with the instructions. These instructions with the highlighted sections will be scanned in and included at the bottom of this video for your convenience. Okay, so they're now instructing us to press the Enter key. Notice that Enter and Increment are the same key. So every time you press Increment, the program counter will be incremented by 1. So now we're at FF02. So we can press Increment many more times and it will continuously increase the program counter. We can also use the Decrement key. So if we're at FF09, pressing Decrement takes us back to FF08. We can press it again and again, and it'll keep decrementing the program counter and showing us the contents of that memory location. If we want to get back to FF01 quickly, you can press the Reset button, and it takes us back to FF01. And the contents of that memory location have not changed at this point. Now they're telling us to type F and C. So if we press the F key, you'll notice it puts an F in the first location and scrolls the data through the display. So now you want to press the C. So now we have FC displayed. Now if you type something wrong, don't worry about it. You can just continue to type and then when you want to put the correct numbers in, you can put in F and then C. So now we have FC displayed again. Okay. It now says to type the numbers 0 and 7 and press Enter. So 0, 7, and then Enter. Okay, so the program counter has been incremented to FF02, and we're now seeing what's in memory location FF02. So now they want us to press 5, 5, and press the Decrement key. So now we're back to FF01 and we have the new data that we typed in 07. Okay, if we press the Increment key, You'll notice the data is not the 55 that we entered, because to enter a number we have to press the enter key for it to store it into memory. If we press the decrement key or reset key, it will not be stored into memory. So continuing on, we're now going to load a program into memory. Now this is the program that they want you to enter into memory. These are the memory addresses, and this is the data that they want you to enter into each of those individual addresses. You'll notice that these codes down here are actually written over here, and they actually have a meaning. So DB is actually the in instruction, and 12 is the actual port location. So here D3 is the out instruction, and we're going out to port 11. You'll notice when you put it into memory locations, it goes sequentially, one after another. But when you're writing out an actual program, we use mnemonics that we can actually understand, and then we have to convert them into data that the microprocessor can understand. So to enter a new program into memory, the first thing they want you to do is press the reset button. That takes us to FF01, and you can see we have 07 stored at that memory location. So they want us to put in DB, and we know we have to press the enter key for it to actually be stored into memory. So now at FF02 they want us to enter 1, 2, and then D3, then 1, 1, C3, 0, 1, and FF. So once you've entered all of those into memory, you can use the decrement key to go back and check that the data did actually get stored into those memory locations. So the next section is on viewing and changing register contents. So when we were entering the data for the program, it was either going into the expansion RAM or the 256 bytes in the 8155 PPI. Now what we're going to be doing is examining register contents. So register contents are actually part of the 8085. So these registers are actually internal to this IC. So looking at the data sheet for the 80C85 that we use in our microprocessor trainer. So on the second page of the data sheet, they've given us a functional block diagram, and I've highlighted the registers that we're going to be talking about in this lesson. We have our arithmetic logic unit in the center here, and it's 8-bit wide. And you'll notice that we have a register out here called the accumulator. That's the A register, and it's 8 bits wide. And also coming off the ALU is the flag registers. And it says here they're 5 bits wide, so there's a few bits that aren't used, and they're flip-flops, so they toggle. Over here we have our register pairs. So we have the B and C register pair, and they're both 8 bits in size. We have the DE register pair. They're both 8 bits. And we have the HL register pair that are also both 8 bits. Now, unfortunately, on this particular data sheet, they had called this the C register, and we can't have 2 C registers. So I've corrected that. This is now the L register. So it's the HL register pair. Below it, we have a 16-bit register called the stack pointer, which we will cover in another lesson. And then we have the program counter, which is 16 bits. The program counter, in our case, is holding the number FF01. So to examine these registers, we're going to hit the reset button, and that should clear all the register pairs to 00. Now we press the function key, And you'll notice in the address register pair 7-segment displays it says func. And then the keys labeled 8, 9, A, B, C, D, E, and F are dual function. So if we want to look at the accumulator and flag register, we press the A key. And you'll notice in data op it says AF, so A is the accumulator. That's these two digits here. F is for the flag register. That's these two digits. So they're saying that they want us to put some data into the accumulator, or A register, and they want us to put in 1F. So when we type 1F, you'll notice it goes into the first two digits, which is the flag register. So in order not to change the flag register, we now have to enter the data that was in there, which was 00. Now we press the Enter key so it stores this information into the accumulator and flag register pairs. To re-examine the AF register pair, we press Function and the A key, and we can see that 1F got stored into the accumulator and the flag register is still 00. We can examine the other register pairs by pressing the function key and pressing B. That shows us the BC register pair. We have the DE register pair, HL register pair. We have the stack pointer, and you'll notice the stack pointer is loaded as FFD4. That's a memory location inside either your RAM, expansion RAM, or the RAM in the 8155. And this is where the CPU stores data as it's running the monitor operating system. We'll talk about the stack pointer in greater detail later. The program counter should be FF01 because that was the last memory location we were looking at. If we want to move to a different memory location, we can go to Function and go to Program Counter. And let's have a look at FF06. So we can type in FF06 and press Enter. And you'll notice we're now looking at memory location FF06 and the data in there is 01. So if you have a large program and you need to jump to another memory location, you can do it by loading the program counter with that memory location you want to go to and then pressing Enter. This saves pressing the increment or decrement key to move long distances. One last thing I want to show you is when you press Function and A, we now have what's in the accumulator in 1F, and we have what's in the flag register 00. But I want you to keep in mind the flag register is actually 8 bits, though we're displaying as a hexadecimal number. So you can see in the lesson they're giving you an example of what's stored in the flag register as 41 being a hexadecimal number. That needs to be converted to binary, and in binary 4 is 0100 and 1 is 0001. Then each of these bits has a significance associated with it. So the first bit is the sign flag, the next bit is the 0 flag, undefined flag, the auxiliary carry flag, the next bit is not used, the next bit's the parity flag, next bit's the undefined flag, so it's not used, and the last bit is the carry flag. So if you remember from digital systems where we added several numbers together, if the digit was actually greater than 1, the carry flag was set. So you can see with our microprocessors, the carry flag is part of the flag register, and the flag register is actually 8 bits that you have to convert from hex to binary to find out if that carry flag was set when you do some kind of math operation. So I'll cover this later when we go through some of the codes that the CPU understands. So I thought we'd do a review using the Primer Trainer simulator. So we turn on the Primer Trainer and we come up with FF01, and the contents of that memory location is 00. Now they want us to enter a program into memory. So at FF01 they want us to enter DB, and we have to press the increment to enter the data into that memory location. So if we press the decrement key, we can see at FF01 we have stored DB. Pressing increment takes us to FF02, where they want us to enter 1, 2, enter, D3, enter, 1, 1, enter, C3, enter. Now they want us to enter 0, 1, but because we already have 0, 0, we can just press the 1, and the 0 was left over from before, so we can press enter. And then they want us to press FF, enter. We can then use the decrement key to take us back. We can use the reset key to take us to FF01. Now if we want to examine the register pairs, we press the function key, and AF is the accumulator and flag register. Now they want us to put data into the A register. They want us to put in 1F, and you notice it shows up in the flag register because it's on this side of the register pair. So we now have to re-enter what was in the flag register, 0, 0, and that moves 1F over into the A register or accumulator. We then have to press increment for it to store that data there. To re-examine the data, we press function, and the AF register pair and 1F was entered in there. If we want to change to another memory location, we can go to function, and we're looking for the program counter, and instead of FF01, let's check what's in FF07. So we can put in FF07 and press enter, and it shows us our program at FF07 is indeed the FF that we stored there. So this concludes lesson number 1. Now in lesson number 2, we're going to be looking at running your first program. So you'll want to subscribe so that you don't miss any of our lesson videos.